Sohan here is our carpenter extraordinaire. You're gonna see a safe that he himself built with the components and everything. It's crazy. So with that, I'm gonna let Sohan take it away for his presentation.
All right. Hi, my name is Sohan, and I'm a rising junior at Xavier High School. And my project is the RFID and fingerprint scanner safe. And the reason why I chose this project is because it involved a lot of hands-on work, as well as an equal amount of code, which suited my interests well, as I really enjoy woodworking and circuitry. I added also a couple of modifications, which will be seen in my demonstration video. All right. So as you can see, before I even start the video, on the LCD display, it asks you to choose an unlocking mode, either 1 or 2. So during the beginning of this video, I'll first go through mode 1.
1.
So as I said, I said the number 1 out loud, which the voice recognition module picked up, and then moved on to the LCD display, asking for the correct RFID card to be scanned. And throughout this process, if you can see those LEDs on the left-hand side of the screen, will turn on when each level of security has been cleared. So now it's the fingerprint scanner. Now, because the correct fingerprint was sensed, the orange light turned on, and on the LCD display, it still says it's locked, and now I have to enter the secret password, which is saying the word open.
Open.
Finally, the green light turns on, the buzzer plays, and the safe opens. In order to lock the safe, there's 2 mechanisms, and the first will be seen right now.
Lock.
You can say the word lock out loud, which will be picked up by the voice recognition module, and turn the servo to lock the box. So now I'm going to show you how mode 2 works. So first, I begin by saying 2 to choose the mode.
2.
So now the blue light turns on, signifying that the next step is going to take place.
8, 3, 5, 6.
And now I'm just
6.
entering a verbal password, which is being picked up by the voice recognition module, and the orange light turns on. And finally, the secret password is a knock, turning the green light on, the buzzer on, and opening the safe. And the second way to lock the safe is to press that button, which essentially resets the code, locking the box. All right. So the main components that I worked with to complete this project begin with the LCD display, which is a 16:2 backlit screen that's able to display characters. I also used a RFID sensor that uses radio frequency to scan a tag with a unique identification number. And you saw that voice recognition module, which is able to capture the pitch of someone's voice and record certain numbers and simple phrases. I also used a fingerprint scanner, which is actually an optical scanner that takes an image of your finger and understands and recognizes the grooves on it to record this data in the scanner. And lastly, I also used a knock sensor, which is essentially a sound sensor, but I set it up so when the vibration from a knock is felt by the sensor, it would set it off. So the main challenge that I ran into during this project was really combining the code of each sensor into my main string of code. Because how I made this project was getting each component working itself and then combining it into my main code. And in order to combine it to the main code, I used a series of if statements and added several variables. And this is what allowed me to have the several different layers of security in the different modes on my project. So the main lesson that I really learned at Bluestamp was that hard work does truly pay off. And the reason why I say this is because I really put a lot of time and effort into adding several modifications and making the wooden box myself, and really felt that this dedication did pay off in the end, as now I have a fully functioning safe that is quite secure. Thank you, and are there any questions?
Awesome job, Sohan. Oh my God. Yeah, guys, it's really cool. Are there any questions?
I have a question. Well, I mean, this is not like an actual technical question, but what was your favorite part to work with that you had? Because you obviously have so many parts in there, but
yeah.
Sure
To be honest, I think my favorite part was that voice recognition module, because I feel like I've never seen it on any other projects. And I just thought it was really cool because it was connected directly to the Arduino. Like usually voice recognition modules might have to be connected through like Wi-Fi or Bluetooth from your phone or something, but this was like a component like directly to your Arduino. So I thought that was really cool.
Yeah, no, that's super cool. Awesome job.
Yeah. I actually I have one more question just real quick. What do you have like a future mod that you want to do with the box?
Ooh, to be honest, I want to add lights in the inside of it. I did want to add lights, but there's actually not enough room on the Arduino board because I had so many sensors. So I think something in the future is I can add like actual nice lights. So when I open the box, the lights will turn on.
I think that'd be sick, man.
That's awesome.
Awesome job, Sohan.
All right, next up, we have Osawese. Osawese came into Bluestamp with 0 building experience, and you're going to see she was able to create a floor cleaning robot. Took her the 3 weeks. She pushed through it, came to office hours, worked really hard, and she came up with an awesome project. Osawese, are you ready? You ready, Osawese? Don't forget to unmute.
Sorry, I was just trying to share my screen.
Awesome.
Sorry. Hi, my name is Osawese. I'm a rising senior at Laboratory of Finance and Technology. So this is just like a quick preview of my project, the floor cleaning robot. So in this project, I really just worked with the moderators, which was like the main part of the project because I had to set it up and then like solder the wires to it. Also I had to work with the Arduino board and using like batteries and the H bridge along with like typing code on my computer. So one thing that was really fun about this project was I would say soldering the wires because I don't know, it just seemed really fun to do. Another thing was like it was pretty difficult to set up everything because it's like kind of my first time doing something like this. So I had like a lot of trouble like getting started off with the right foot. But after like coming to a bunch of office hours and like working on the project and like looking at more tutorials on like how to make it, it really came through. So yeah, that's it for my project.
Awesome job. I'm going to start off with a question. What did you like better? Did you like the building of the car better, or did you like the coding better? Because they're two pretty opposite sides. Like, do you think you have a preference? Because coming in, you had no experience, you said. So this is like a first impression. How does it feel now that you finished?
I liked building the robot better because I worked with code a lot, so it wasn't like nothing new. But after like building the robot and then connecting it to the code to make it work, that was kind of cool to me. So it was like a new element of engineering and stuff. So
Yeah, having it all come together at the end is like the best feeling. Like you can combine two separate elements, combine them into one. Awesome job.
I also have a question. Will this project inspire you to do more like engineering in the future, or is this like a one-time thing that you're gonna do?
okay, so this project was really fun to do, although it was really hard, but it makes me want to do more engineering in the future because it makes me want to do like other cool things. Like I looked at my project now, I was like, damn, did I make this? Like it was just kind of surprising because I never made anything in my life like that. So yeah.
Awesome job.
Awesome question, Dylan, too.
Yeah, great question. Next up is Eden or Eden. Sorry.
Yeah, it's Eden. Next student is one of mine, Eden, and her project's really cool. She implemented 2 mods, which she'll tell you about in her project. But she was our local Scribble champ of my room. So Eden, if you could take it away.
Hi, my name is Eden, and I'm a rising junior at SR High School. And my base project for demo night was a line following robot, but I modified it to also make it a light tracking robot. So before I get into like the details actually of how this works, I just want to, if you'll wait 1 second, share a video of this actually working. Just wait 1 second. All right, so here is my robot car, right? And the first sort of mode that it has is following a line. And right, you just push a button, turn it on, and then it'll start following a line. Now, the second mode right here is that it can also follow light. So I'll just use a flashlight right here to actually show how it follows the light. All right, so that right there is and for a more like in-depth explanation of how it works, basically on the front of the robot, it's a little hard to see, but there are two IR sensors. And the IR sensors detect the difference between black and white, and that's what allows, oh, sorry. Oh, and the IR sensors are what allow this robot to detect the difference between black and white. And then there are also, if you can see here, 4 photoresistors, 1 on each end of the robot. And that's what allows this robot car to actually follow light. And so over the course of this project, there were a lot of minor challenges. There wasn't really anything major that I had to deal with, just a lot of minor challenges, right? There were soldering took a while, coding issues, just a lot of minor things. Also though, I initially wanted to create a solar modification, right? And have this but unfortunately the materials actually didn't arrive in time. So instead I just took what I had, which I had some photoresistors, and I allowed it to follow. Look at that mute. And this all sort of gets into the final like takeaway, what I learned from this experience. Because yes, I wanted to do a solar modification. Yes, I wasn't really planning for it to be a light tracking robot, but I just learned that by like doing it by myself, adding whatever I wanted, I just had a great time with it. And I really love how my project turned out right now. Hopefully in the future, I can maybe add a solar modification, but I have a line following, light tracking robot, and I'm really happy with that. So thank you.
Awesome job,
Any questions?
Yeah, does anyone have a question? Feel free to jump in. I have a question then. Eden, so for your project, were the photoresistors kind of like working right out of the gate, or did you have to like implement something for like to get all the photoresistors working together?
I would say the photoresistors themselves working. I mean, the coding part of that, like I said, it was one of those like challenges, like just debugging it took a bit of time, especially like getting them all to work, making sure that the light could shine on all of them. But eventually I got there, and yeah, I'm really happy with how it turned out.
Awesome. Awesome job. Yeah.
Thank you.
Yeah, that's awesome. That's a really, really cool project. Next up, we have Dalen. Dalen was my student and also Sam's student. He has 2 projects that he's going to present, one right after the other. Both of them are super cool. Put in a lot of hard work. He's guy always tries to get everyone to smile, which is really nice to have in like a small environment. Always getting people to laugh, always getting people to smile, always has something to say. Sam will give him another little brief stuff, and he'll be ready to present.
Yeah, Dalen was definitely bright light in our group. I'm really excited for you guys to all see the work he put in. So Dalen, if you want to take it away, or you want to start with the laser turret?
Yeah, thank you. So yeah, my name is Dalen, and I'm a rising sophomore from Success Academy HSLA. And the project I picked was the laser guided turret, and this is it right here. Initially, I picked the project because it sounded cool, and I was right in my assumptions as it was really fun and cool to build. So yeah, let me give you a demo of it. So the laser turret actually has 3 modes so far. Right now it's on its base mode, it's off mode. And we just a push of the button and it'll switch to its next mode. This is this automatic firing mode in which both servos and the laser module just starts blindly firing all over the place like a turret. And then with a click of another button, it is now in its manual mode where I have a firing button to make it fire, and I can control it using potentiometers on this breadboard, as you can see by the gold parts on it. As you can see. And then finally, one more click of button, and boom, it's back to its off mode. This laser turret was actually really fun to build, and however, with fun comes a lot of struggle. And as you can see, the laser turret, although it may look small, it had to use a lot of wiring in order to actually get it to work. And through that, a lot of wires got plugged out. I had to reinforce some wires with alligator clips, but it was all worth it at the end when I got this amazing project, right, which I could show off in the future to family, friends, and even new job offers. And for that, I'm thankful to my instructor, Sam. And before we move on from this project, I actually have a sneak peek for you guys of wireless connection that I was working on with Sam during office hours. So let me just share the video for you real quick. All right. So right here, we have two separate ESPs that are plugged into two different ports. We have one with a potentiometers attached to a breadboard, and the other one with another servo attached to it. And so these are two completely separate ports. And if I were to turn one potentiometer, then the servo on the other side would start moving because of wireless connection, as you can see. And so, yeah, that was just a little sneak peek of me and Sam we're working on, and I hope you enjoyed it. And before I ask for questions, I actually want to demonstrate my other project as well. Here is my other project, Simon Says. And what this is basically like, the regular memory game that you usually play. And I'm just gonna do a little play test demo for you. So boom, I press this just to start a game. Oh, it seems like I accidentally lost. And as you can see, actually, one of my modifications was adding this red light to blink whenever you lose a game. And yeah, that's just something extra I've been working on. And this project was actually more wiring based, which I really enjoy since I usually love to fiddle around with a bunch of different wires. However, as you can probably tell, this was not easy to code, and it took many lines of code, over 400 actually. And I actually have Field to confirm that. And however, I did manage to get through it since Field was there to help me, plus some online guys that I used. And with that, I really got to enjoy the full aspect of the project, failures and all. And not only that, but I also got to experiment with different LEDs in order to make my project more colorful. And I even ended up changing the yellow to an orange one, which makes it look even better. And yeah, that's my project. And that was what I was working on for my 3 weeks at Blue Stamp. Does anyone have any questions?
Awesome job, Dalen.
Awesome job, Dalen. Yeah, I was gonna say, do you have any modifications that you want to add to either project now?
Actually, yes, I do want to keep on working on getting the wireless connection for the servos, even after my time Blue is about to end, since I just think it's a really cool modification to add. And for Simon Says, how I have like a red light to indicate you're losing. Yeah. I also want to add a rainbow light to indicate when you win, and a green light to indicate when you got the correct sequence when you put in the buttons.
Awesome.
If no one has another question, which was your favorite instructor of me and Fio?
Now, that is a question I cannot answer, no matter how many times you ask me that.
Darn it.
I have a quick question. So, Dalen, have you thought about how you're gonna display these two projects or where you're gonna store it?
Actually, yes. So for the laser turret, I actually built a little cardboard stand. I actually made it myself, even though although it's not as good as Sohan's, woodworking skills. It's just a little something DIY that I put together myself to just hold up the turret. And I don't really have a plan, first timers right now, but I'm sure I think it's in the future.
Awesome. That looks
Awesome
great.
job, man.
Awesome
That's
job,
great.
Dalen. All right. Next up, I had in my group 4 separate kids who chose the same project, which is the gesture controlled car. So instead of having you guys hear the same 4 presentations over and over again, we're going to have each student kind of delve a little bit into each separate component so that you can get a deeper understanding. And also I'll keep the entertainment a little bit smoother and we'll be able to smooth sail through everyone's presentations. So with that, I want to first call up Daniel Wong, who's going to tell us a little bit about the motor driver. So Daniel, I really kind of learned a lot from Daniel, I'm going to be honest, because 2 of the chips that were sent to Daniel came broken. And even though that would be enough to kind of bring someone down, kind of lower morale, Daniel kept on pushing through and ended up making some modifications to his project to compensate for the fact that he was missing a vital component. So with that, I'm going to hand it off to Daniel. Daniel, are you ready?
Yep. Hi, my name is Daniel. I'm a rising freshman at Berkeley High School, and I'm making the gesture-controlled robot. So I chose the gesture-controlled robot because cars have always been really interesting to me. And so when I saw that you could create a car that you can control with your hand, I just thought that was really cool. So I'm going to be showing you guys the motor driver, which is right in the middle of this thing. So what is a motor driver? A motor driver is what we use to control the circuits. There are 2 things needed to make a motor spin. You need a control circuit and a motor driver. Well, a control circuit runs on low power signals, but a motor requires a lot of power to spin. So a motor driver takes a low current and turns it into a high current signal. Motor drivers use something called an H-bridge. H-bridge are made up of 4 switches. These 4 switches, when they're opened and closed, can reverse the direction of a current, which can cause the motor to reverse or brake. When the switches are closed, they cause the motor to come to a sudden stop, which is why when coding the speed of a motor, we only use high and low. For my project, I had a lot of trouble with my ESPs and getting my power into my car motors. And I think that the hardest component for me to use was the motor driver. But these past 3 weeks, I really enjoyed working on this experiment and working around the problems with coding and connections. Are there any questions?
Awesome. That was awesome. I do have a question. So you said your least favorite part, the hardest part to work with. What was your favorite part?
I really like using the accelerometer.
Yeah, the accelerometer is awesome. That's awesome. Does anyone else have any questions? If not,
Oh, Sohan's got a question.
I can't see everyone. All right. Yeah, whoever has a question.
So I was just curious on how you were able to like have the wireless communication between like the I guess the gesture portion and the actual car.
So
Well,
yeah, Daniel, go for it.
well, I wasn't able to do that because I only had 1 ESP to use. So right now my accelerometer is actually like stuck to my car, but over the rest of the summer I plan to finish it.
And we're going to hear from Daniel Satari about how that connection works. You're going to have to wait after this presentation. Daniel's going to go, so you'll be able to hear a little bit more about that then. So you can look forward to that. So next up, we have Praneet. Praneet spent a lot of time coming to office hours, making sure he really understood all the nuances of the code, all the nuances of how the components. He'd always ask me questions, trying to really understand a deeper understanding of each component so we could create a better project. Praneet, are you ready?
Yes, thanks, Phil.
Okay.
All right, everyone. Hello, my name is Praneet, and I'm a rising junior at Irvington High here in California. And the project I built was the gesture controlled car, similar to both the Daniels and another one of my friends. And one of the most important components of this gesture controlled car was the accelerometer Daniel and Theo were talking about earlier. Now, although this accelerometer is very handy, the built-in 3-axis gyroscope was the one that was much more useful. The reason being that this 3-axis gyroscope read angles in 3 distinct directions: direction X, direction Y, and direction Z. This means that in order to make my car move forward, backwards, left, and right, or just swerve, I needed to figure out from which I can use this little module to control the entire car. So let me show you how that works in code. Okay, so as you can see on the left of my screen, this portion, this is a little bit of code I wrote. And the first thing I do want to point out is this little segment. So this little segment is converting the initial units of the accelerometer, which is radians, to degrees. And the reason why this was easy to work with for me, so I did that. And then after that, inside the loop, which I created right here, I began with figuring out or playing around with the accelerometer and figuring out which directions were associated with making the car move forward and making the car move backwards. Soon I figured out that was the Y direction. And therefore, I then figured out a range. So any range of values that the serial monitor reads greater than 30 degrees and less than 80, that would make the car move forward. And the serial monitor would print out move forward, as you can see on the right hand of my screen. The same concept can be applied with moving backwards and left and right. Now, if the serial monitor does not read any of these values inside these ranges, then the car will stop as the serial monitor will print stop. And the Z direction I was talking about earlier, this is also very useful. However, I did not implement it in my project since all 4 directions, forward, backwards, left, and right, were covered. However, one modification, which I will talk about later, I plan on adding will be associated with the Z direction. Now, without further ado, let me show you guys the serial monitor on the right. This is a little bit of a snapshot I took from the serial monitor that I was printing out while I was running this. So moving forward, it will essentially print out when I tilt this accelerometer forward. And then right beneath it, you guys can see 35.54 up here. That is the exact degrees of angle I've tilted the accelerometer in. And again, the same concept can be applied with all of these other readings. And I'll show you guys a quick demonstration of my car. So give me 1 second. Okay, so as you can see, this is the car right here. And this is the accelerometer in my hand. So as I tilt this accelerometer forward just a little bit, all the wheels will move forward. As I tilt it back, all the wheels will move backwards. And again, the right and left will work in the same way. However, for right and left, the car will rotate on its axes as in respect to the direction, one set of wheels will completely turn off or move backwards, and the other set of wheels will go. Now, how the 332s are connected and what they are, I believe Daniel Saptari will talk about that. But something I did want to mention is that I had a lot of fun building this car, and I'm planning to add a lot of modifications, such as a camera, an ultrasonic sensor to detect obstacles, and a laser light, which will be associated with the Z direction. So it can turn around as my car is moving in any direction. Thank you very much for listening. Are there any questions?
Awesome job.
Yeah, I have a question. So now that you have like an actual gesture control car working, is there a way you think that you might be able to make it airborne, like make any time in the future? Are you going to be like researching into that?
That would be extremely cool, Dalen. I can definitely look into that. That's an amazing idea you just gave me. There's still 1 month left in summer, so I might look into that. I don't know why it wouldn't be possible. I mean, what's wrong in trying it out? So I'll try it out and let you know.
Yeah, I have one question. What was the most complicated bug? Because I know so many bugs come up throughout the code, or throughout the project building. What was like the hardest one that you had to overcome?
So the hardest one, I believe, I'm not sure if this was like a foolish mistake or it was actually difficult. So this was the motor driver, which Daniel Wong talked about earlier, was connected to the 4 motors distinctly. So essentially, I thought that motor driver had short-circuited since none of my motors were working. And then later, after around a week of debugging, Theo and I figured out that the problem was with the 9-volt battery pack. And that 9 volts of voltage isn't enough to sort of function all 4 motors simultaneously.
Yeah, that was a really difficult bug to figure out, but I'm glad we figured it out in the end.
Absolutely.
Awesome job, Praneet. So next up, we have Daniel Saptari, not Daniel Wong. So Daniel worked really hard. He had some delays in the beginning with his kit, but he really pushed through, came to office hours, and really made the most of his time and was able to complete a really awesome project during the 3 weeks. Daniel, are you ready?
Yeah, hi, I'm Daniel. I'm going into 9th grade at Lexington High School, and I also did the gesture controlled car. So I'm going to be talking about how the two ESP32 chips communicate with each other wirelessly to control the car. So the way it works is the sending ESP that's on the glove um, sends information to the ESP on the car. And it does this by like sending it to its MAC address. And the way it's used in the project is first, the accelerometer sends data to the ESP32 on the glove. And then the ESP determines what the car should do based on like the angle or the degrees. I'm also gonna show the code for that. So on the left is the code for the sending ESP. So as you see in this if statement, this is the range of like the angle, and depending on the angle, it'll send certain information to the ESP on the car. And the car ESP has statements in the code, has if statements in the code as well that determine what the motors will do depending on what information it receives. So in this if statement, if it receives the message forward, then it'll do this with the motors to make the car move in different directions. And let me show you guys a video of, oh yeah, just as disclaimer, I'm like a really bad driver with this thing, so I crashed like a couple times. So yeah, the hardest part of this project was for me was working with was getting the two ESPs to be able to connect with each other. Mainly just because it was very new for me and I had like a couple bugs with it. And my favorite part of the project is working with the accelerometer because I just found it cool how something so small could get so much data and just like transmit that through just two wires. So yeah, are there any questions?
Yeah, I have a question actually. I see on your project in your video that you're actually using, or there's an ultrasonic sensor on the top.
Oh yeah,
Oh,
that's a work in progress. Yeah, I just haven't gotten that to work completely yet. I also am thinking about uh adding a modification where instead of it just going forward, back, left, right, or stop, like it can like speed up and go like different speeds depending on how far you tilt in certain directions.
awesome. But wait, so what's the work in progress mod that like I guess it'll turn out to be? if I may ask?
Probably at first I was gonna do so that it wouldn't like hit any walls because as you saw before, I'm not really that good driving. But I might also make it so that um I might actually change where it is so that it doesn't fall down the stairs because yeah, because that would be even worse than crashing into a wall.
Yeah. Oh wow.
Also,
Yeah, that'd
I
be
have
really
a final
cool.
question.
Yeah, Dylan, go ahead.
So when is the race between you and all of the other builders of the gesture control cars?
Oh, I don't know. I don't have an
Gotta
answer
have
to
one.
that question.
We gotta make one. We'll make one tomorrow. We'll set up a distance or something. That'll be fun. But awesome job, Daniel. Sam stole my question. I was gonna ask you about your modifications, but really awesome job. Last but not least with the gesture control cars now is David. So David was the first one to finish his car, finished it pretty early, which allowed him time to implement his modification in a little bit early, and he was able to finish that before presentation today, which is awesome. So Dave's going to tell you a little bit about the modification that he did, which is really cool. David, are you ready?
Yeah. So hi, I'm David, and I'm going to be an incoming senior at Leland High School. And I also did the hand gesture controlled car. And the modification I added was the ultrasonic sensor. So here, let me share my screen. Um, so this is how it basically works. So it would emit sound waves at a frequency where we humans wouldn't be able to hear, and then it would reflect back, and then the sensor would receive that, and that's how it calculates a distance between the sensor and an object or a wall. And this is the formula for the distance, and it's in centimeters. So basically, the ultrasonic sensor, it is very similar to echolocation. And how I used it in my project was that like when it detects like a wall at a certain distance, my car would just stop. And this is what it looks like. So my car is going forward right here. And then when it detects that, it just stopped like that. And I also added an LED to my car right here. So whenever the car isn't in motion, it would light up. And the part where I struggled the most in this project was probably the two-way ESP. And my favorite part of the project was definitely doing the accelerometer because I just found it really cool how it could like detect angles and like the rotation of from such a tiny like object. And overall, I had like a super fun experience, and I would definitely want to do more projects like this. And is there any questions?
Awesome. That was great, David. I do. If you could change one thing, like going into the project, like there's one thing you could add right now, what would it be? Like it instantly appears like programmed in that you could add onto your project right now.
Maybe like a microphone to it, like where I could just talk to it. I don't know.
That'd be like a
Something like
voice,
that.
like a
Yeah,
voice
yeah.
controlled.
Like I put it like a speaker on it, and then I have like a microphone in my hand, and I could just like talk through it.
That'd be super, super cool.
Or like a camera.
Yeah, those are awesome.
I have another one. So why did you choose this project in the beginning?
Yeah, I was just always really interested in like self-controlling robots. Like I'm like really into like drones or like just like RC cars. So yeah.
It's pretty sweet. Yeah. Drones are really cool.
Yeah. Awesome job, David. Next up, we have Abir. Abir came into Blue Stamp with a really good idea. He wanted to make a 3D roller coaster. Came in with zero experience. He really learned a lot over the last 3 weeks, and he was able to create something really cool. And I have no doubt in my mind Abir is going to continue on with this in the future because what he's been able to do in the last 3 weeks has really been amazing. I'm excited to see kind of where it goes after Blue Stamp also. But without further ado, Abir, are you ready?
Yep. Hi, my name is Abir. I'm a rising senior at Homestead High School in California, and I decided to do a 3D printed roller coaster as my project. And the reason I chose to do such a project is that ever since a young age, I've kind of just found roller coasters to be this one fascinating thing, and they've always just amazed me on how they're so safe, but also so thrilling at the same time. And I've always wanted to just create one myself, and I decided to do that here at Blue Stamp. So I'll share my screen really quickly. Okay, so this is Onshape, the 3D CAD software that I used for my project. And this is just a part of the track that I created. And to create this, I pretty much just created the first left half of this track. And then after I did this, I mirrored it over to have a full track. And after I had the track, I needed to have some sort of car that could go on it. So to do that, I split it up into 3 components. First, the wheels, which I designed to look like this so that they could fit on the track. The axle for the wheels, and also the body of the car, which goes through which has these holes for the axles. And then to print it, I sort of And also to know the dimensions, I used the assembly feature and it ended up looking like this. And I actually also have it printed with me right here. See this, it's not glued together, but it's kind of hard to see, but yeah, I can send a picture. And so I'd say that the hardest part of all of this was definitely working with precise measurements and just becoming familiar with Onshape in general. And my favorite aspect was 100% designing things, seeing them being printed, and then being able to hold them later. And in the future, a big sort of modification that I'm definitely going to do is add a chain and have it go up a hill. And I have the chain right here actually, which I will put on later, and using these gears that are also in Onshape. And so after these 2 years at Bluestamp, I definitely learned that the type of engineering for me is definitely the design side. So any questions?
Awesome job up here. I just want to give like a disclaimer, like learning a 3D software in 3 weeks is such a big deal. I took a class on it this past semester, and like it's so much information that you're able to have to take in at once. And Avir's really done a crazy, amazing job at learning this in only 3 weeks. And with that, I kind of want to, I know you're working on the track part or the ramp part. Do you want to show that off, show kind of what you're working on for the future, a little sneak peek for everyone?
Like the part that goes up?
Yeah, let's see because I know.
Yeah.
They've been working hard on that. You spent the beginning time working on that.
Yeah.
I like it. It's super, super cool.
So it's, the dimensions are a bit off, but I think I have it somewhere. Somewhere here. Yeah, so something like this. Obviously the track is a bit too big, but something like this, I'd slap a chain onto here. There would be supports with a hole going through it with axles, and then having gears here, and then there'd just be a chain that runs like this. And also what I'm working on is adding a latching mechanism, sort of. It's kind of just a little piece that is connected to the car that can latch onto the chain and be brought up. And then maybe in the future, I'll even add something down here, who knows? Yeah.
Awesome, man.
It's so cool. Really, really awesome job. I know how much time and effort you put into this. And like, it's amazing what you're able to show off. Like you have a physical 3D thing that you've printed by yourself.
Yeah.
Really, really awesome job. And
I
last,
think Dalen has a question real quick.
Yeah, Dalen.
I was gonna ask, like, are you planning to like 3D print like each part and like connect it to make the full roller coaster?
Yeah, so actually at the beginning of the first week, I was attempting to create an interlocking mechanism for each track, since my 3D printer is not big enough to obviously print the whole thing. So yeah, I'm definitely gonna look into that after I do the chain lift. Yeah.
It'd be awesome, man. Awesome. Yeah, I can introduce last. So last but certainly not least is Tanvir, and Tanvir himself is also doing a custom project, which he'll introduce now. And he's put in a ton of work the past 3 weeks, and we've had some serious bugs the first week, but he like persevered, and his project is turning out to be really, really cool. So Tanvir, if you want to take it away.
Hi, I'm Tanvir. I'm a rising senior at Brooklyn Tech, and the project that I've undertaken at Bluestamp Engineering was to create a custom controller. And the reason why I wanted to start this project was because I had a problem on one of my current game controllers about stick drift, which is due to mechanical degradation over time. And I was thinking to myself how I might resolve it, and that kind of evolved into, what if I just tried to make my own controller design? And that's where I got this project. So let me share my screen and show you what I have for the demo video. So I have multiple components, as you can see here. I have 2 control sticks. The one I'm holding first, the one on the right, is going to be used for mouse movement. And if you click down on the button, it should also click your left mouse. And on the left, we have the WASD control, where if you click down on the button, this will cause you to press space. Typically, WASD is used for game movement. Finally, we have 4 push buttons, which is meant to mimic the arrow keys and going in order from left to right. Each key corresponds to left, down, up, and to the right. So in this example, you can see that I'm going to move my cursor to press insert coin, and then I'll start playing Pac-Man both with the push buttons as well as the movement joystick. Some of the other components I used was the Arduino Micro, and originally I had intended to use an ESP32, but I ran into a lot of problems with Bluetooth connection, and at the midway point I decided let me just change it to this other microcontroller, see how that goes. And it actually went pretty well. Unfortunately, the Bluetooth aspect isn't here, so one thing I might focus on later is to try to implement it in another iteration of the circuit. And very soon after this, I'm going to transition to the other tab using the movement stick, using the mouse movement stick. And that one's just to show that the whole thing works if you wanted to like drag your mouse over a certain point while holding it down. One problem that you might notice here is that the cursor itself is moving very, very slowly. This works fine in isolation, but the moment I combined all the code together, because there's so much running at once, it really slows down the whole thing. Yeah, overall, I really enjoyed my time at Bluestamp so far. I think the best part so far was like getting to just seeing my computer being taken over by my controller and seeing like I'm making remote inputs without even having to touch anything else. So that was cool. Definitely thinking about other mods in the future, probably a gyroscope control so that I can physically move the controller and that'll give out inputs as well. And yeah, I definitely learned that time management is super important, especially when you only have 3 weeks to do something. So yeah, I'm gonna improve on that and see how it goes from here. Any questions?
Awesome job, Tanner.
That's awesome.
Such a cool project.
That's super. Yeah, that's really, really cool. And I just have one question. Do you have any plans of putting it like making like 3D, like designing maybe like a actual controller case for it, or are you gonna kind of leave it as it is or put it in a box or something? Do you have any plans for like a housing component?
Yeah, that's a good point. I'd start first to see if I can solder the whole thing together. And then after that, I definitely consider some sort of casing for it so I could get a more ergonomic design.
Awesome. That's awesome.
Awesome job, man. Yeah. Is there any other questions? Awesome. All right. In that case, I think we can start wrapping it up.
Yeah, so I just want to thank everyone for coming. All the students, like a big round of applause for you guys. You guys all put in so much effort, so much
Awesome
time,
job, guys.
countless hours. Really, and you guys all did an amazing job. You guys will have all this project to show off for the rest of your life. I have my project that I worked at when I was at Bluestamp still in my house, sitting on my desk in my room, in my apartment now. But when I go home, it's just sitting right there in front of me. Me and Sam will always be here if you guys want recommendations in the future. You could come to us if you need help choosing a major. If you want to do mechanical engineering or electrical engineering, come to us. We have lots of experience with this stuff, and we're always here to help you guys. But you guys did an amazing job the last 3 weeks, and I'm excited to see where you guys go in the future from here. I just want to thank everyone for coming. Yeah, Sam, do you have anything else to add?
Yeah, awesome job, guys, these past 3 weeks. I'm so proud of all of you. You guys freaking knocked it out of the park. It was crazy. Updates, guys, don't forget to finish your websites.
Yes, come to class tomorrow.
Come to class tomorrow. We're not over yet. We still got one more day.
But yeah, once your websites are up, I sent mine out when I was applying to colleges, applying to other internships, and they're super helpful. Bluestamp will write you great recommendations. We'll write great recommendations. But you guys all did amazing work over the last 3 weeks. So we're really, really proud of you guys.
I spent 3 weeks with you guys. I can write a great recommendation letter.
It's true. And like seeing you guys build projects, like that's the best you could do. Seeing someone in like an experience with our building projects, that's what engineering's all about. And you guys all did a phenomenal job. So that yeah, you guys are free to leave. We are done as of now. So
Done with
thank you
demo
guys
night.
all for
Thank you guys
coming.
so much
We'll
for
be around
coming.
for questions if you guys have questions
Yeah.
with anything. We'll stick around for a little, but
yeah, I'll see you guys tomorrow.
you guys
And
tomorrow.
parents, thank you so much for turning out.
yeah, thanks for coming. It was really great, like seeing everyone. Having a bigger audience is always better, and like showcasing for everyone's work.
Thank you. Thank you. Good
Bye.
job, everyone.
Great
job.
Bye, guys.
Bye.
We just end it.
I guess. Yeah, I'm gonna end the recording.
Stop recording. Yeah.